All right, so this starts number 13, this big section, and the key instruction that you need to pay attention to on this large section is method of your choice. You can pick any method of our three to do these problems. Those three are graphing, elimination, and substitution. Any of those methods works, okay? I tend to favor the first two, so most of the ones I do, I'm gonna try to do with one of those first two methods. I look at this one and we learned if they're already lined up for you, our X's, our Y's, and our numbers are already all lined up, then it's probably easiest to do elimination. And I would pick that for this one. This is a -6 and a +8. I can turn them both into the same number and they're positive and negative, which is good. But 4 and 5 are also negative and positive. And to me, that's an easier switch because I can think and easily see that I can turn these into both being 20, okay? So 20 is my goal number. I want to multiply this top equation by a +5. So that goes away. I'm multiplying by 5. And I want to multiply this bottom equation by 4. That's going to create a -20 and a +20, which will cancel. So when I do this first multiplication, I'm going to erase these different three methods. I need this room up here. When I do this first multiplication, my result is a -30x minus 20y equals 90, I think. No, 80. Sorry about that, 18 would be 90. My second set of multiplications, I get a 32x. Good, those are going to be a nice little almost cancel to a 2x. A +20y. And a -88. Now I'm ready to run elimination by adding these two equations together. When I add these together, I get my 2x. These cancel out, and that equals a -8. So when I divide by 2 and divide by 2, I get that x equals -4. That's half my answer. I need to plug it into one of my original equations. Both of these are pretty equally easy equations, so I'm just going to plug into this one so that I can write it right under here. When I plug in -4 for x, I have 8 times -4 plus 5y equals -22. That's -32 plus 5y equals -22. Add 32, add 32. Those are going to cancel. 5y equals a +10. Therefore, y is going to equal 2. That's my other half of my answer. I put them together, box it in, and there's my full answer. There's my solution. Don't lose sight that a solution is just where these cross an intersection. That's why you could also graph it. Number 14 takes a little bit of prep work. I can't get started on it just yet. I've got to get rid of these decimals. So I'm going to multiply both equations by 10, giving me 2x plus 6y equals 36, and 4x minus 9y equals -12. From here, it's pretty easy to see. Again, I think I'm going to tackle this one with elimination. You don't have to. But I think that's probably the easiest because they're already lined up. And if I just multiply this top equation by -2, I'm going to get a -4 here, which cancels out. So I get -4x. I'm working with this top equation, minus 12y equals -72. I run my elimination process by adding these two things together. Those are going to cancel. I'm going to get a -21y equals -84. Then I divide by -21, divide by -21. Say a little Hail Mary in prayer and make sure that these go into each other evenly, and they do. Y is going to equal a +4. Okay, that's calculator work right there. I'm going to take that -4 or a +4. I'm going to plug it into one of my original equations. I wouldn't go all the way back to original. I would actually go to where we edited these and made them nice whole numbers because they're just easier to work with. I like this top equation. It was 2x plus 6y, but we know what y is. Y is 4 equals 36. That's 2x plus 24 equals 36. Subtract 24. 2x equals 12. Divide by 2, and x equals 6. That's the other half of my answer. I write them together as a point because it's an intersection. I box it in. 15 starts getting really tough. Okay. 15, I look at and I say, golly, nothing's even written the right way. I don't know what's going on. I don't know which method I want to use. Couple options. A lot of people look at this bottom equation and they see if I just move both of these pieces to this side, I'll have x by itself and I can run substitution. That's fine, but I know most kids don't really like using substitution if they don't have to. I also see that if I just do a bit of rearranging, I've got 3y and negative 3y that'll cancel out right here on the left side. So let's do that, okay? Let's move 9 over to the other side. And then also, I'm going to go ahead and write the 3y in front. This is a positive x and a positive 3y. So I can write this 3y in front. Left side equals 9 because we added 9 to it. Now, if I can just kind of not pay attention to this stuff, I can see I'm ready for elimination with the original equation and the one I've reworked a little bit. I add these together. These are going to cancel. I get a negative 4x equals 12. Therefore, my x is going to equal negative 3. Half my answer. I've got to go back and I've got to plug it into one of my original equations. I already kind of drew a bunch of crap and lines through that second one, so let's just work with that first equation. It was negative 3y minus 5x. Well, x is negative 3 equals 3. Negative 3y. This is going to be a positive 15 equals 3. And so we're going to subtract 15. Those cancel. I get that negative 3y equals negative 12. Thus, y equals 4. When I put those together, I get one answer, and that answer is negative 3, 4. That's my intersection point. Number 16, another problem where I look and I say, golly, everything's just thrown all over the place. How am I going to do this? Okay. Well, I also look and see over on the left side of my equal signs, I've got a negative 2x and a positive 2x that'll cancel. So I know elimination is going to be a very good option here. All right. I'll show you some other ones that are graphing on the next couple. I don't really do much substitution. It's a great method, substitution. Okay. It really is a great method. But this is personal preference right here. If you want to see any of these done with a different method, just come in tomorrow morning and I can show you how to do any of these problems with any of the 3 methods. If I want to line everything up, I'm used to them all being in standard form, okay? If I want to put this top one in standard form, I've got 12 plus 2x equals negative 3y. I would subtract 12 from both sides and add 3y to both sides. These are going to cancel out. This 2x plus 3y do not add together. And then I'll have a negative 12 on that side. For my top equation, it's a little bit easier. I just have to subtract 12 from both sides. And then rearrange my left side a little bit. So I like the x's to be in front because my x's are in front over here. Negative 2x minus 3y equals negative 12. And now I'm starting to look and say, oh, something weird's going on here. These equations look a lot alike. Well, let's run them with the elimination method. Okay, I'm just going to take this equation and write it under here because that's what I need for elimination. 2x plus 3y equals negative 12. And I'm going to add these things together. I'm going to add them together. When I do that, my x's cancel and my y's cancel, and I get that 0 equals negative 24, which I know to be a false statement. Therefore, I have no solution.